Okay. Okay, let's start it. Hello guys, welcome to the fifth lesson of DBA from Introduction to Practice. I'm your old friend 𝘔𝘂𝘏, the global technical evangelist for OceanBase. It's great to have you all here as we dive into another exciting topic of OceanBase. Today, we are focusing on how to manage and operate OceanBase efficiently. Whether you are a beginner or an experienced database administrator, this lesson will give you valuable insights into the tools that make managing OceanBase a breeze. We will be covering a variety of tools, including OCP for centralized management, OBD for easy deployment, 𝘖𝘤𝘦𝘢𝘭𝘰𝘍𝑜 for Kubernetes-based operations, and the OceanBase CLI for those who love working with the terminal. So, without further ado, let's get started. We will introduce you to the following four parts using OCP, command line, OBD, and OB operator for operation and maintenance. OCP is the first part we will introduce. Why OCP is recommended for operation and maintenance? The first one is GUI operation is easy to customer to use. The second one is OCP is designed specifically for OceanBase with a high focus. The third, OCP has open API, custom monitoring line, high flexibility. The fourth, OCP supports user and rule management with high security. We also have two preconditions for using OCP. One, OCP and OBD do not jointly manage a cluster. The second, MetaDB and a business cluster are not shared. In the process of using OCP for operation and maintenance, we mainly introduce the following 6 modules. They are taking over a cluster, migrate out of a cluster. The third is backup and recovery. The fourth is upgrading a cluster. The fifth is cluster expansion and reduction. The last one is node replacement. What are the log files of OCP? When deploying, we need to know 2 logs. They are bootstrap log to record the process of initializing the MetaDB. The other one is OCP log during the deployment. When using, there are also some kinds of logs we need to know. They are the OCP server log and the OCP agent log. Taking over a cluster is common operation. As you can see from the picture on the left, there are 2 ways to connect: direct connection and OB proxy. What's the difference between the direct connection and the OB proxy connection? The answer is there is no difference. OCP connects to the cluster to obtain takeover information, and a proxy connection requires more configuration information. When users take over a cluster, they may receive some pre-checks error. They are common errors. The reason is that the default IDC or region information of OCP needs to be consistent with the actual configuration of the cluster. You can modify the OCP metadata or the cluster zone information using the following 3 cycles to maintain consistency. Or you can modify OCP meta tenant metadata related table. They are compute region, compute RDC to maintain consistency. If there is an error when executing a takeover task, most of them are due to pre-check failures, such as a clock diff command not have permissions. After taking over the OceanBase database cluster, we also need to take over the OB proxy cluster. In this process, we may encounter some problems, such as 1. Cannot find the takeover OB proxy entry. The answer is you need to deploy 𝘂𝘵𝘁𝘁 cluster first and initialize 𝘂𝘵𝘁𝘁 related metadata information. Second, an error occurs when taking over an 𝘂𝘵𝘁𝘁. There is a few things you must pay attention to before taking over. Just like we only support 𝘂𝘵𝘁𝘁 cluster takeover deployed by OCP, not OBD deployment. And the newly deployed 𝘂𝘵𝘁𝘁 needs to associate it with the connectable OceanBase cluster of the 𝘂𝘵𝘁𝘁 to be taken over. And it would be best if you take over the corresponding OceanBase cluster first. And the version of the taken over 𝘂𝘵𝘁𝘁 service cannot be too different from the current 𝘂𝘵𝘁𝘁 cluster version. And the last one is the 𝘂𝘵𝘁𝘁 cluster service to be taken over is the normal status. After migrating out the OceanBase database, we can also migrate out the 𝘂𝘵𝘁𝘁 cluster. This part is similar to the content of migrating out of the OceanBase cluster. Similarly, we use 3 questions to understand how to migrate out of the 𝘂𝘵𝘁𝘁 cluster. The first one, will the migration of 𝘂𝘵𝘁𝘁 affect the service of existing connections? The answer is no. Migration will not affect the normal use of 𝘂𝘵𝘁𝘁. You can still use the taking over function to restore it, or other OCPs can do so. The second, what other restrictions are moving out? The restrictions are the same as those for migrating out of OceanBase cluster. The last one, what to do after moving out? This part is the same with migrating out of the OceanBase cluster. But please note that migration deletes the attributes of 𝘂𝘵𝘁𝘁. Next, let's look at the problems you may encounter when using OCP for backup and recovery. This section is divided into 3 parts. The first is backup media. The second is data backup. And the third is data recovery. The premise of data backup is backup media. OCP supports backup media just like NFS, OSS, and COS. NFS is often used as a backup media. Please refer to the official website for steps to deploy NFS. We will understand backup media through 2 questions. First one, what should you pay attention to when using backup media? The answer is different media have different version requirements, so you need to pay attention to when using them. Just like NFS media requires NFS 4.1 and above, OSS media requires OceanBase 4.1.0, and COS backup media requires OceanBase 4.2.1 and above. The second, multi-node cluster must use backup media. Single node and test environment can be backed up locally, but there are security risks. The second aspect, common issues with the NFS storage media. The NFS nobody user and the OceanBase process user must have access rights to the backup directory. This ensures that both the NFS nobody user and the process user can properly interact with the backup directory. And the NFS client need to be deployed and configured on each node in the OceanBase cluster. After preparing the storage media, you can use OCP to start data backup. Currently, OceanBase supports tenant level and cluster level data backup. The screenshot on the left is the OCP data backup operation interface. We can see that there are storage types, just like file, OSS, and COS to choose from. There are also storage directories. Backup medias the backup methods and setting for the automatic cleanup and of expired backups. Data backup includes the log, archive backup, and data backup. Data backup can be performed only when the log archive backup status is doing. What are the limitations of data backup and what should be paid attention to? The first one, the sys-tenant and meta-tenant do not support data backup. Only business tenant can be backup. The second one, data backup is not supported for cluster in the upgrading state. The third, the cleanup of data backups must follow the principle of full plus incremental equal complete data. If there is only one full backup, the cleanup of the full backup will not be triggered. Even if the expired backup cleanup retention period is reached. The fourth, it's recommended to perform a compaction before backing up. The first backup must be a full data backup. The fifth, it's forbidden to directly delete the files being backed up manually using the RM method. This operation may cause achieve log backup to fail, data backup to fail, and others. The sixth, deleting a backup policy on OCP will not delete the backup data files. If you are sure that the backup data can be discarded, you may manually delete the backup directory using RM command. The seventh, the last one, if the recoverable time field is blank or the source tenant information cannot be selected in the backup interface, it might indicate that the OB-admin file is missing from the bin directory of the OceanBase installation deployed with OBD. You can resolve this by extracting the OB-admin files from the OceanBase package installer package and placing it in the bin directory. After the previous data backup is completed, we can use OCP to restore the data. The screenshot on this page is the OCP data recovery interface. From the operation interface, we can see a storage type, storage directory, parsing host, restore source information, restore destination information, and others. Data recovery includes log archive backup and log backup, and data backup. Data backup can only be performed after the log archive backup status is doing. What are the limitations and points to note when recovering data? First one, it's recommended that the database version of the target cluster and the source cluster be consistent. The next, OceanBase currently only supports restoring backup data of lower version to the same or higher version, but does not support restoring backup data of OceanBase version 3 to OceanBase version 4. The next one is special version. The backup data of OceanBase version 4.0.x version does not support restore to OceanBase version 4.1.x and above versions. So please pay attention to that. The next one, if the recoverable time is blank and the source tenant information cannot be selected in the recovery interface, it may be the OB-admin file is missing in the bin directory of the installation directory of OceanBase deployed by OBD. The last one, by default, the target tenant of the backup and recovery will form a primary standby tenant relationship with the source tenant, and the data synchronization will be performed at the same time. If the synchronization status needs to be released, the primary standby tenant can be decoupled. Next, let's see how to use OCP to upgrade a cluster. Before upgrading the OceanBase service with OCP, you need to confirm whether to upgrade OCP. OCP has container deployment and OBD deployment methods. Upgrading OCP also requires upgrading according to the deployment method. It's recommended to use the OBD web update GUI mode to upgrade. You only need to fill in the root at OCP meta password. If the container-based version of OCP, this method will reinstall it as a non-containerized version. If you still need to use the container-based version, you can obtain the new version image for a container-based upgrade. We also need to note that OCP nodes need to install the Java environment. Currently, only JDK 1.8 is supported, and the build version number must be at least 161. When upgrading the OCP deployment in the container will be closed and the new OCP service will be deployed again using the RPM package. Container management will no longer be used. After completing the OCP upgrade, you can upgrade the OceanBase database. What should I pay attention to when upgrading the OceanBase cluster using OCP? 1. Before upgrading the cluster, you need to upgrade 3 OceanBase software packages. They are database package, database and dependency package, and database 2 integration package. The next, before upgrading the cluster, it's recommended to confirm the corresponding version upgrade instruction. For example, the current OceanBase version 4.2.1.3 does not support upgrading to OceanBase version 4.2.x. But it will be supported later. Next, before upgrading a cluster, the cluster status must be granted to be healthy and normal. It's recommended to upgrade a cluster that is in operation and maintenance. The fourth, when upgrading a cluster, if a cluster environment is greater than or equal to 3 zones, a rolling upgrade is recommended, which can be upgraded online. Please note that if your environment is single zone, it does not support rolling upgrade, and the database will be stopped during the upgrade process, affecting business use. You need to apply for the upgrading time window in advance. Next, when upgrading a cluster, if a cluster with more than 3 zones uses a rolling upgrade, you must ensure that all tenants have more than 3 replicas before upgrading. Otherwise, the upgrade pre-check will fail because tenants cannot guarantee a majority during the upgrade process. The last one, when upgrading a cluster, pay attention to the fact that you cannot roll back the cluster upgrade task when completing the pre-check for upgrade phase. If a task fails, do not manually skip or roll back it or set it to success. This may cause irreversible damage to the cluster and endanger business protection. You need to connect OceanBase technical support for assistance. After completing the OceanBase upgrade, you also need to upgrade the 𝘠𝗶𝘁 cluster. What should I pay attention to when upgrading the 𝘠𝗶𝘁 cluster using OCP? The first, when upgrading an 𝘠𝗶𝘁 cluster, all 𝘠𝗶𝘁 servers in the cluster will be upgraded at the same time, so the 𝘠𝗶𝘁 cluster will stop providing external services. If the current OP proxy cluster is already carrying services, it's recommended to upgrade the OP proxy service in the cluster in batches according to the currently configured load balancing. The second, when upgrading an OP proxy cluster with multiple CPU architectures, if the selected installation package version is missing in a certain CPU architecture, the upgrade will fail. In another word, you need to upload the software package of the corresponding architecture. The last one, the package version cannot be lower than the current version. Next, let's look at a core operation, cluster scaling out. OceanBase had two scenarios for adding or reducing nodes, combined with the picture on the left. Adding or reducing nodes horizontally will increase or decrease the number of zones, thereby controlling the number of tenant replicas. And adding or reducing nodes vertically will increase or decrease the number of OB servers, thus controlling the upper limit of tenant resources. What should I pay attention to when using OCP to scale out the number of OceanBase cluster zones? 1. Before scaling out the zone, you must include 3 OceanBase installation packages in the software package management. And next, before scaling out the zone, you must add a host first. It's recommended that the server be initialized first. 3. Before scaling out the zone, the cluster needs to be in a healthy status. Next, when scaling out a zone, if the expansion task fails, rollback is supported. If the rollback fails, it's not recommended to skip the task or set it success. You need to connect the OceanBase technical support for assistance. The next, after the expansion of the zone is completed, a copy will not be automatically added to the tenant. You need to go to the tenant management and click the required tenant to add a copy. The last one, after the expansion of zone is completed, if the primary zone is the sequential priority strategy, the cluster computing performance cannot be increased. If the primary zone is a random strategy, it generally has some impact on the performance of the partition table, which depends on the business usage scenario. For example, a partition table after the expansion, the partitions will be scattered to more nodes. The number of partitions per node will be reduced, and the computing speed will be improved. But the more nodes are coursed, the more network I/O will be increased. After completing the cluster expansion, let's see how to use OCP to expand the capacity of OceanBase tenants. There are 2 scenarios for scaling out tenants. In the first scenario, increasing the number of cluster replica can enhance the disaster recovery capability of the entire cluster. For example, if the entire cluster has 3 zones corresponding to 3 replicas, if one zone has a problem, the entire cluster is still available. But if two zones have problems, the entire cluster is unavailable. But if the entire cluster consists of 5 zones, then when 2 zones have problems, the entire cluster is still available. In the second scenario, adjusting tenant unit specification to increase the upper limit of tenant resource usage. There are 2 scenarios that are independent and have no dependency. What should I pay attention to when using OCP to scale out tenant replicas and unit specifications? The first one, OceanBase version 4 to version 4.2. only supports full-featured replicas. The second, OCP version 4.2 and above, support full-featured replicas and read-only replicas. The last one, when increasing the unit specification, it's recommended to keep the tenant's log disk 3 to 5 times the size of the tenant's memory. Next, we will introduce how to scale out the entire cluster. Vertical expansion is to add OB server nodes to an existing zone, which can increase the upper limit of the zone's resource usage. For example, a 111 architecture cluster is vertically scaled out to a 222 architecture. 111 architecture cluster means the entire cluster has 3 zones, and every zone has just one OB server. After the capacity is expanded to a 222 cluster, 2 OB servers will carry the load of the original 1 OB server. It effectively enhances the overall performance of the cluster. We also have some precautions for vertical expansion and the tenant unit adjustment. First, before scaling out the OB server, you need to add a host first. It's recommended that if the server be initialized first, before scaling out the OB server, you must include 3 OceanBase installation packages in the software package management. The third, before scaling out OB server capacity, it's recommended to maintain consistency resource configurations with the source cluster servers. This ensures efficient resource utilization and minimize waste. And next, before scaling out the OB server, the host of the expanded node needs to be consistent with the host of the cluster architecture. For example, CPU architecture. The fifth, before scaling out the OB server, the cluster status needs to be running. The next, when scaling out the OB server, if the expansion task fails, rollback is supported. If the rollback fails, it's not recommended to skip the task or set it to success. The last one, after scaling out the OB server, the tenant's data will not be automatically balanced to the new node. You need to go to the tenant management, click the required tenant, and modify the unit to generate the same unit's resource pool on the newly scaled out node, and balance the tenant data partitions under the same zone to the new node. The steps for scaling in a cluster are the reverse of scaling out. Before scaling in the cluster, you need to scale in the tenants first. During the horizontal scaling in a zone, the tenant replicas must be removed first. Considerations for scaling in tenant replicas and horizontally scaling in zones. The first one, before deleting a replica, the OceanBase cluster and the tenant must be running. Operations are not allowed in other status. The second, before deleting a replica, you need to ensure that the tenant's replicas can satisfy the majority after deleting the replica. That is, a tenant with 3 replicas can only delete 1 replica at most. The next, before deleting replica, it's recommended to proactively switch the primary replica by modifying the tenant's primary zone priority to ensure that the replica deletion does not affect the business. The next, before scaling in zone, ensure that there are no tenant replicas on the zone. This requires scaling in the tenant replicas first, and the tenant replicas can be deleted in batches. The last one, when scaling a zone, if a scaling task fails, rollback is supported. If the rollback fails, it's not recommended to skip the task or set into success. You need to connect OceanBase technical support for assistance. Vertical scaling involves reducing the unit number of the tenants to free up resources before scaling in OceanOB server nodes within a zone. Consideration for scaling in tenant replicas and vertically scaling in zones. There are first one, before scaling in tenant unit, it's recommended to merge tenants to release the memory being used by its tenant and improve scaling efficiency. The next, before scaling in the tenant unit, you need to ensure the remaining disk resources and the remaining OB server nodes are sufficiently to support the data of the scaling in tenant. The third, if you need to scale in a specific OB server node, you need to manually migrate the unit. The fourth, when the OceanBase cluster is version 4.2.0 or above, the tenant parameters enable rebalance is false. The number of units cannot be modified. The next, in multi-zone cluster scenarios, OceanBase version 4 and above do not support reducing the number of units in a single zone, and the replica types only support the full-featured replica types. That is, for a 2-2-2 architecture cluster or tenant, a tenant can only be scaled in to a 1-1-1 class architecture. The next, before scaling in the OB server, you need to confirm that the tenants of the scaled in OB server node have been migrated. The last, when scaling in OB server, if the scaling in task fails, it's not recommended to skip the task or set it to success. In our daily operation and maintenance, there may be node failures or relocation of the computer room, and the cluster nodes need to be replaced. There are two scenarios here. One is when there are idle machines available for replacement, and the other is when there are no idle machines available for replacement. When replacement is needed and there are idle server resource, the replacement needs to be paid attention to. 1. The cluster must be available. That is, the tenant can be accessed normally through the cluster. 2. The idle server needs to match the current cluster hardware architecture, and the host needs to be in the same computer zone as the original host. The next, the idle server's hardware and software resources need to be greater than or equal to the failed node, especially the disk capacity. The fourth, before replacing the server, you need to add a host first. It's recommended that the server be initialized first. Next, before replacing the server, OceanBase and OCP agent software package must be available in the software package management, and the versions must be consistent with the source cluster. The sixth, when replacing a server, if a 14-node OP server is offline, you need to follow the prompt to skip the host operation during the replacement process. The seventh, when replacing a server, if a replacement task failed, it's not recommended to skip the task or set it to success. The last one, after replacing the server, if the node has OB proxy services deployed, you need to deploy or add the OB proxy for the node. When there is no replacement server, please pay attention to 1. If the server fail can be repaired in a short time, you can adjust the permanent offline time parameter, server parameter offline time first, and then stop the OB server process. The permanent offline time need to be evaluated according to the time it takes for the server to be repaired and put back online. The second, if the server fails cannot be repaired properly in a multi-zone, multi-OB server cluster, you can consider manually migrating the unit to other nodes within the same zone, provided the remaining OB server nodes have sufficient resources to accommodate the migrated unit. Once the migration is complete, you can proceed to delete the faulty OB server node. The last one, if the server fail cannot be repaired in a short time, and the cluster is a multi-zone single OB server cluster, you can consider the cluster scaling solution. Next, let's introduce using the command line for operation and maintenance. We have more than 50 commonly used cycles to operate OceanBase. They include cluster-related cycle, cluster resource-related cycle, and table partition and distribution-related cycle, dump and merge related cycle, execution plan cache related cycle, and collecting statistics related cycle, and others. For the detailed information, you can check it in the official website. Next, let's look at some common problems in the operation and maintenance process. There are mainly 5 types. The first one is how to obtain database log information corresponding to SQL status. It has 2 scenarios: get the trace ID with or without error. The second one is how to collect information about slow SQL performance. It also has 2 scenarios: when SQL execution is particularly slow or DDL is blocked. The third one is how to troubleshoot database initialization fails. The fourth one is how to troubleshoot logs when database upgrade fails. The last one is how to collect stack trace information after the OB server node crash. Next, let's talk about how to obtain database log information corresponding to SQL statement. When SQL cannot be executed repeatedly, we can view the audit wheel, find the exception information, show the SQL statement, and obtain the trace ID and server IP information. Log into the machine corresponding to the server IP and filter the log information by trace ID. The issue in different exception scenarios may not always be found in the OB server log. For example, if the backup command fails, the cause of the error can be analyzed in the root service log. So we need to search the content of these 2 logs. If the audit information is purged, the database system log are flushed, or the system log level is too low, you can configure the parameters such as set the log level to WDIAG, and set the number of logs to be returned. Wait for SQL to be executable to reproduce the problem, and then obtain the log according to the above process. When SQL can be executed repeatedly, the idea of troubleshooting is similar to that just now. You can first check the audit wheel in the above way to troubleshoot. The first scenario is if the SQL execution reports an error immediately, using the system tenant to obtain the trace ID is recommended. Log into the system tenant and turn on the enable reach error message parameter, and log into the business tenant and execute the error reporting SQL statement. Then go to the server node whose IP address is reported in the error message to filter logs. After obtaining the log information, turn off the enabled reach error message parameter. Next is the second scenario. If the executed SQL statement returns success, but the SQL task has not been completed, it's recommended to use the business tenant to obtain the trace ID. We can log into the business tenant and set the OB-enable show trace variable. Execute SQL statement to obtain trace ID. The method can only return trace ID. You need to use the audit wheel to find out which server IP address to filter the logs. In the end, you can filter the logs by the server IP and trace ID obtained above. You can also filter multi-logs by regular matching if the latest log cannot be filtered. Next, let's introduce how to collect information about the slow SQL. We recommend you first through 𝘖𝘤𝘦𝘢𝘐𝘐 to this tool will help you add the show tracing function in the full link diagnosis, or check the audit wheel to confirm the events affect the execution time. We generally obtain the SQL execution plan, review and analyze it, and retrieve SQL plan monitor information to identify the root cause of the slow SQL. We can analyze the causes of slow SQL through the following 8 steps. You can watch them after this lesson. I won't go into details. How to troubleshoot when DDL execution does not return. Is it being executed or stuck? Many modules are involved in troubleshooting this problem, such as RS scheduling, exceptions, log conflicts, RPC, or high business pressure, and others. First of all, we can get the information of the DDL currently being executed. If it can be obtained, it means that there is an exception in the RS scheduling stage, and we need to filter the information from root service log by trace ID. By the way, do you remember what is RS? RS is the root service in OceanBase cluster. It's responsible for resourcing, scheduling, resource allocation, and data distribution information management, and also schema management of the entire OceanBase cluster. There are many reasons for this kind of problem, which I will not introduce in detail here. You can join OceanBase GitHub or Slack community, where we will help you analyze and solve the problems. Next, let's talk about how to troubleshoot database initialization fails. Many people will encounter this problem when they first deploy OceanBase. Most of the reasons are caused by unreasonable resource parameter setting of the entire cluster during the deployment phase. When troubleshooting, we need to pay attention to the fact that no matter whether the database is deployed using OBD or OCP, we must look for error information in the OB server log, not in the OBD or OCP log. I also note that initialization can only be performed once. Let's view the difficulties encountered in the initialization phase log. 1. The logs were overwritten during the initialization phase. The next, there are too many logs and the failed log information cannot be found. The last one, the log levels were not set correctly and the key information was not printed. Corresponding to these difficulties, we also have some solutions. 1. Set the number of system logs to retain. 2. Find keywords. In addition to checking the error level, you can also look for the error keywords in the initialization phase or the log print information. Begin server limit report when the database is started. The last one, set the system log level to WDIAG. Let's talk about how to check logs when a database upgrade fails. Whether OBD or OCP is used to upgrade the database, the upgrade is performed by calling the database upgrade script. If the upgrade fails, the cause of the problem cannot be confirmed through the logs of these tools. You need to pay attention to the following 4 database upgrade logs. We also need to note when OBD executes the upgrade database command, the upgrade log is located in the current directory. The upgrade log is located in time when OCP performs a database upgrade. After the OBD database upgrade command fails, you can execute the upgrade command again. And you cannot give the task directly after the OCP fails in the database upgrade operation step. Here are also some tips need to know. Just like the log format will be standardized in future versions, and the subsequent versions, users will not be allowed to skip crucial steps in the OCP upgrade process if they fail. Next, let's talk about how to collect the stack trace information after the OB server node crash. The OB server may crash and generate core files when encountering serious failures. Usually, the OceanBase needs to locate and confirm such problems and provide some logs and stack trace information. Let's first look at the configuration of the core file. If not configured, the core file will not be generated in the home path of the OceanBase database by default. You can view the current resource limited through your limit command. If it is set to 0 or very small, core files will not be generated. Then we filter the key information in the OB server log by keyword and print the stack trace information. After collecting or backing up the required troubleshooting and analyze information, you can try to manually restart the OB server service process to see if it returned to normal. If the core frequently fails to recover through restart, consider replacing the node if the cluster is available or increasing the permanent offline time to prevent the node from being kicked out of the cluster. If the cluster is unavailable, consider restoring data through data backup files and switching to the physical standby database to restore business. Next, we will introduce using OBD for operation and maintenance. Let's first look at the directory using OBD. First, the cluster directory is used to store the configuration file corresponding to the deployed name. Adding the configuration file directory is not recommended. It would help if you use the OBD cluster added config operation. There is a data file that records the deployment name, component related information, and the deployment status information. Modifying this configuration file directly is not recommended. The next is the log directory. It's used to store OBD command operation logs. And next is mirror directory. It's used to store the installation package of the local warehouse and the repo file of the remote warehouse. The following is the plugin directory. It's used to store the component-related plugins. The last one is version directory. It's used to record OBD version. There are 3 steps to adjust the OceanBase cluster parameters using OBD. 1. Using the command OBD cluster list to view the deployment name. 2. Use the command OBD cluster edit configure to edit the cluster parameters. 3. Use the command OBD cluster reload or restart or redeploy to make the parameters effective. There are something to note when adjusting cluster parameters. The first one, if you are not sure whether the parameters adjusted by edit configure take effect after the reinstallation, restart, or reload, you can refer to the files searched by the command. 2. Principles to follow. Parameters in the deployment configuration file should be modified using OBD cluster edit configure. Parameters not in the deployment configuration file can be modified using the SQL command in the database. If you are not sure how to modify the parameters in the deployment configuration file, check the parameter YAML file and modify it. The third, when editing the resource parameter and the OceanBase CE module, please note that the data file size parameter does not support the reduction. When adjusting cluster resources, you need to follow the principles. 1. When increasing the parameter value, do not exceed the remaining resources of the server. When decreasing the parameter value, ensure it does not fall below the allocated occupancy range of the tenant. When adjusting tenant resource parameters, you need to follow the principles. And when increasing the parameters value, do not exceed the remaining resources of the cluster. And when decreasing the parameter value, the minimum tenant memory cannot be lower than the limit. 6. When decreasing the parameters value, the minimal tenant CPU cannot be lower than 1 core, and the max CPU cannot be lower than mini CPU. The last one, when decreasing the parameter value, the tenant log disk size parameters is recommended to be 3 to 5 times the size of the tenant memory. Next, we will introduce how to use OBD to restart manage the services. There are 3 scenarios in total. 1. Restart all services under the deployment name. 2. Restart the specified service and the deployment name. 3. Restart the specified service and the specified node under the deployment. There are some things to note when restarting. 1. The precondition for restarting a component is that the nodes involved in all components need to be connected with SSH. Otherwise, the restart operation cannot be performed, even if the IP node is specified. 2. When all components are restarted, the status of the comprising deployment name is the OBD cluster list will be running. If an element fails to restart, the subsequent components will not be restarted. The third, the status of deployment name in the OBD cluster is not obtained in real time and will only be updated after the management operation is completed. The first, if the deployment name status is not running, it will affect the subsequent management operation, such as upgrades and expansions. The next, the component name refers to the module name specified in the deployment configuration file, not the name displayed by the OBD cluster display command. The next, when specifying multiple component names, use commas to separate them. Next, when restarting a specific service component separately, the deployment status will not be updated. For example, when all services are stopped, the deployment status is shown as stopped. Even if each component is started separately, the overall deployment status will return stopped. If multiple IPs are specified and there is an incorrect IP, OBD will skip the incorrect IP and only restart the correct IP. The last one, if multiple component services are specified and there is an incorrect component name, OBD will terminate the entire restart operation. Although OBD is an installation and deployment tool, it also supports upgrade functions. Before using OBD to upgrade the database, we need to check and upgrade OBD first. We recommend that you use the latest version of OBD and then upgrade the database. There are still something to note on the upgrading OceanBase with OBD. 1. Before using OBD to upgrade, if the cluster has primary and backup tenant, it's recommended that both the primary and backup cluster be upgraded to the same version. Before using OBD to upgrade, you configure the upgrade instruction in the release notice of the target versions. And the following notes I will not introduce in detail. Please watch them after this lesson. Okay? And next, let's introduce how to use OBD to scale out the management services. The OBD cluster scale out component command will update the new node expansion configuration to the source cluster deployment configuration file and perform an environmental pre-check on the expansion node. If it passes, OceanBase will not be installed on the expansion node and the service will be started and added to the source cluster. We have two simple steps to scale out the management services. 1. Write OceanBase expansion configuration file. We can see the configuration file contains information such as nodes, IP, port, and directory. The second, scaling out OceanBase services. There are also some things to note when using OBD to scale out OceanBase. 1. Before scaling out, you need to check whether the OBD version needs to be updated. It's recommended to use the latest version. The second, before scaling out, it's recommended to initialize the server and the expanded node first. The deployment user and the SSH connection information must be consistent. The third, before scaling out the capacity, you need to ensure that the OceanBase cluster is in a normal state. Before scaling out, you also need to ensure that the OB client has been installed. And the configuration files of the expanded node is not allowed to modify the dependency, global or the server configuration in the original cluster configuration. You only need to configure the basic information of the new node. Therefore, it's necessary to ensure that the resource configuration and the directory mounting the expanded node server are consistent with the original cluster server. This is, after scale out, you need to add copies to the tenant. Otherwise, it will still be in a single copy tenant. The next, after capacity scaling out, it's recommended to adjust the tenant's primary zone priority as needed. And cluster reduction using OBD is not supported yet. After scaling out, vertical scaling of OB server nodes is also supported. To achieve this, specify the source cluster zone in the expansion configuration file. Once the scaling is complete, tenant resources can be scaled horizontally. Next, let's introduce using OB operator for operation and maintenance. The current OB operator already provides user with an interface for managing OceanBase cluster in Kubernetes through the dashboard, calling Kubernetes API to implement OceanBase resource management, including a basic overview, cluster creation, tenant creation, and others. Currently, only the community version of OceanBase database image are supported. For example, For complete operation and maintenance document, please refer to the official website. Okay? If you have any questions, it's the perfect time to ask. Okay, no questions? Okay, before we wrap up, I'd like to remind you that our next lesson will be on the evening of December 9th, where we will be covering the business development of business community edition. We look forward to seeing you then. You can also reach out anytime through our OceanBase GitHub, Slack, or Discord community for further assistance. We are always here to help. We will sharing how you can access the course materials and today's presentation slides in the comments section of this video. All the resources are free. Don't forget to subscribe to our OceanBase YouTube channel and join our community to stay up to date and get involved with us. See you guys. Bye bye.